Hey everybody, welcome back to another fun and exciting geometry class. Today we are going to be on page 133. 133, we're going to be talking about equal arcs, actually a lot of different things about arcs, and we're going to be starting off in lesson 3.2. 3.2, page 133. All right, so the theorem there, theorem 32, talks about equal central angles intercepting equal arcs. Here's the idea. If the central angle is congruent or the same, if it's the same central angle or a congruent central angle, and the circle is the same, then the arcs that they intercept are going to be the same. Notice it also, the converse is true. Equal arcs subtend equal central angles. So if the arc is equal, then the central angle is going to be equal. And I really talked a lot about this in the last lesson. This is just kind of a review and taking it to the next step here, next level. The next thing that is there in your book, and this is on page 134, talks about chords and how chords subtend or determine arcs as well. So if I have a chord, and the chord goes from this point to this point, let's say, and we'll label that. We'll call this point A, and we'll call this point B. The chord, even though it's not a central angle, okay, so even though it's not something like this going through the center point, okay, so that's a central angle. This is what we've talked about already, is where the central angle is subtending the arc there. But here, the chord, notice that the chord, the definition of the chord, there's an endpoint A and there's an endpoint B. It is determining an arc, okay? So the chord subtends or determines the arc. So we could say that chord AB or line segment AB determines, or we could even say equals, the arc AB. Now that's not exactly right. It doesn't equal it. So we can't really put that because it's not exactly the same. Because think about it, like if you measured this to this, and if you measured this around here, obviously the arc is going to be longer because remember we talked about the shortest distance between 2 points, and here's the 2 points, A and B. The shortest distance is that straight line. This is going to take you longer to go like this. Think of if your house is A and the grocery store is B, and you're going to walk from point A to point B or drive from point A to point B. Going from point A to point B in a straight line, that's the fastest way to get there. But maybe there's something, maybe there's like a river or something that you have to go through, and the only way to get there is by taking the bridge. And here's the bridge across the river. So you got to go over to the bridge, and then you got to go back to the store. It's going to take you longer, but you can't get there on the straight line. So the idea here is that it's not equal. So we can't write equal to, but we can write that it subtends or it determines. So notice this right here. This line, the length of this line determines how long this arc is. Now, you could go in a different direction. I mean, you could go way out here and come back, okay? But I'm talking about following the circle, the curve of the circle. That line determines the length of that arc right there. So we could say here that line AB determines arc AB. Chord AB determines arc AB. All right, next is on page 130. Actually, there's a little bit more on 134 that I wanted to show you, and that's corollary 32. Let me go back. Corollary 32 says if the same circle, congruent circles, two central angles are unequal. So this is like going back to this theorem right here, and this theorem says if the central angles are equal, then they're going to intercept equal arcs. But in the corollary, it says, well, what if those central arcs are not, or central angles are not equal? Well, then the thing goes on to say that the bigger central arc is going to subtend the bigger angle. And we've already seen that. You know, I could use this one right here, and I could say, okay, so this is a 70-degree angle. And let's say that this is a 110-degree angle. Well, it's obvious that the bigger angle is going to subtend the bigger arc. Same thing is true here with chords. What happens if we put another chord in here, but this other chord is smaller? Let's make it real short, okay? And so this is CD. Well, chord CD is smaller than chord AB. So arc CD is going to be smaller than arc AB. Okay, see the relationship between all those. Really, these lessons are all about relationships so that you understand, okay, if this is bigger, then that's going to be bigger. Okay, if that's smaller, then that's going to be smaller. Okay, if this is equal, then this is going to be equal. So it's trying to understand the relationship between the central angles, the chords, and the arcs. Page 135. Page 135. Now we have equal chords. Now, one thing, please don't ever say chords for that. Okay, that drives me crazy right there. So it's not a chord. I don't know why it's spelled like that. I don't know why they put the CH. You would think if they're going to say chord, then it would just be C-O-R-D-S. Okay, but for some reason they put the H in there. But it's not chord. Don't say chord. Okay, it's a chord. That's a pet peeve of mine, so don't say that. All right, and Theorem 33. Theorem 33 says that in the same or congruent circles, equal chords subtend equal arcs. In the same or congruent circles, equal chords subtend equal arcs. We've kind of already talked about that when we talked about chords. The converse is also true. So if they're not equal, then they're not going to subtend equal ones. But if they are equal, and then here's the other thing, equal angles will, or equal arcs will subtend equal chords. All right, so let's go down to these circles. I'm going to say that these are congruent circles. The yellow circle is congruent to the pink circle. And I'm also going to say that, so let's do this. AB is equal to CD. Okay? We're going to say that those two lines are the same. Let's say that this is 5 inches and this is 5 inches. And we're going to say that the circles are also congruent. Okay, so the circle has to be congruent. It wouldn't work if you had a little circle and a big circle or something like that. Then everything would be different. But in this case, the circles are the same. The chords are the same. What else is the same? Well, it would have to be arc AB would have to equal arc CD. This arc right here has to equal this arc right here. Why? Because this subtends. And if that's subtending the same, if the subtending chord is the same, then the arc has to be the same. That's what the theorem says right there. All right, next, go ahead and skip over to page 136. Page 136. Well, what about unequal chords? What about unequal chords? Well, in this case, now the chords are not the same. On the last one, we just had equal chords, so AB equaled CD. Well, what happens when the chords are not the same? So I've got one chord bigger than the other chord, for example. Theorem 34 says, in equal or congruent circles, so again, we're starting with congruent circles, if two chords are unequal, the larger chord subtends the larger minor arc. All right, so let's go to this. And that word minor arc there, I put it in a little emphasis. I underlined it. Why? Because, watch this. Check this out. Really, AB has two arcs, right? AB has one arc right there, but look, AB, you could go this way. Okay, maybe you've never thought of that. So AB has a minor arc and AB has a major arc. This is the way that we deal with arcs. We're always talking about the minor arc unless you specify and you say, okay, the major arc AB. And there's a way to write that. We'll get to that in a few lessons. But so major or minor. But if you're talking about if you're just talking about the arc, you're talking about the minor arc. You would have to say major arc to be talking about the back side here of this circle. So whenever we say arc AB, we're talking about this minor arc AB. And I think you can pretty clearly see that AB is smaller than, it's less than CD, right? CD is bigger. So what does that tell you about the arcs? So this is line AB, or chord AB is less than chord CD. What does that tell us about the arcs? Well, let's see what the theorem says. The larger subtends the larger minor arc. So that means that CD, arc CD, has to be bigger than arc AB. So AB is less than CD. So there's a direct correlation there. If the angle is bigger, then the arc is bigger. If the chord is bigger, and the angle was from a few lessons ago, if the chord is bigger, then the arc is also bigger. So it's a direct correlation between the two. All right. Let's see. I think that's all I have for you today. So let me see. Oh, one more thing. The converse is also true. Whenever we have this, it would also be the same if we were talking about the lesser arc. So if I was saying, okay, so then that would mean if CD is bigger, then that would also mean that AB is smaller. They're directly related. But now watch this. This is interesting. Let me erase this. Let's talk about the major arc for a second. The major arc works backwards. So look at the major arc for AB. Change the color here. The major arc for AB is bigger. So let's call it the major arc, or the major arc for AB is actually greater than the major arc for CD. And that works because of this, because of there's 360 degrees, okay? And if this minor arc was bigger, then when we subtract it, then the difference is going to be smaller. That's kind of one of those ones that goes back to the whole the equality things that we just did, axioms for inequalities. When we subtract unequals from unequals, then they're equal, or they're unequal but in reverse order, and that's what's going on here. We're subtracting unequals from 360, and so the major arc for AB is actually going to be greater than the major arc for CD. Now the minor arc, AB, is going to be smaller. So in other words, this part of the arc, let me change that color, this part of the arc is smaller than this part of the arc for CD. And I think you can see that. It's pretty obvious, right? CD, the pink part is much larger than the pink part on AB. But the blue part on AB is much bigger than the blue part on CD. So you can visually see that there. Not always can you visually see it, because what if the arc, or what if the chord is very, very close to the same size? What if they're both, one is 5 inches and one is 5.1 inches? Well, you're not really going to be able to see it with your eyes. You're going to have to just trust the inequality notation right there. All right. All right, that's all I have for you. Hope you learned something today. If you didn't, just rewind it, take another look at it, and try to work on some of those practice problems, try to do some of those proofs, and try to use some of this stuff in those geometrical exercises there that they give you. Practice makes perfect. All right, we'll see you later. Bye-bye.